For some of us, the perception of halogen light is still attractive and valid, not only because of the smoothness of the spectral distribution, but mainly because of the low color temperature, which is attractive and makes our souls feel at home, reminiscent of ancient heritage and the fireplaces and the caves. Psychologically, the higher color temperatures may occasionally be more inspiring because, especially the blue, suppresses the generation of melatonin and thus makes us more awake and alert. Metal halide in daylight for a long time was very spiky, had peaks of each of the chemical elements and components, and the valleys in between. My new HMIs now have absolutely perfect color all across the spectrum. And amazingly, we now can say that the same highest possible color quality is consistent all throughout the entire lifetime. The song of the day for a long time now has been LED, which in the beginning was not without its own problems. And it took us 10 years to find our way to perfection. Today, we don't go deeply into all the different ways of evaluation of LED and CRI, only 8 colors, expanded CRI, 15 colors, TLCI, Television Lighting Consistency Index, very important and a big step forward. TM3015, another expansion for the evaluation. We know that older color temperature meters are no longer valid for such critical comparisons. Spectrum analysis is the way to go to test the best possible LED. But that is only one part of the story, because there are huge differences between the perception of the human eye and the sensors in our cameras. TLCI mainly referred to the perception of studio cameras with 3 CCD sensors, whilst most other cameras work with CMOS sensors. And for me, the major problem was that such cameras, even if they have the same manufacturer's name, react very different to LED light. So, you could have a perfect LED light, but imperfect and distorted colors in the resulting images, jumping off the ideal Planckian curve into green or magenta, which is totally detrimental for skin tones. A Canon 5D Mark II could show very different color, as opposed to Canon 5D Mark III. Arri Alexa and some of the red cameras are relatively forgiving, but many of the other cameras jumped into totally different directions. Even analyzing RGB-WW LEDs and adjusting their spectral composition according to the sensitivity of one particular sensor or one particular camera sounds and is a very good way, but it is not applicable for the next camera. Also, there are influences by different low-pass filters applied in practically each of those cameras, and also the optics and their coatings. Therefore, we took great pains to work with what is most important to me in our profession, and that is the depiction of humans. And most of those come equipped with skin. Therefore, we took many different varieties of human faces. Light one side of the face with a reliable reference light, and the other side with the LED light to be tested. Originally, we found horrible differences. It took us 10 years to work on the development of LEDs that would cooperate with all the different sensors in a similar way and show congruence between reference light and LED light on both sides of a face. We conducted such tests in an endless row of shootings with Scandinavian skin, Mexican skin, Ethiopian skin and Angolan skin. Finally, we achieved results that are pleasing and congruent without distorted colors. Of course, you don't necessarily need to shoot with different light sources in the same set, but sometimes this is unavoidable. To have succeeded in finding LED color that agrees with all the different sensors was a great relief and an end to my nightmares. You can find some of the videos that we produced already years ago, showing criteria, different spectrum analysis devices, and our procedures. We also managed to place perfect daylight LED chips together with perfect tungsten LED chips in a checkerboard array in a very small footprint. So we don't lose the advantages of the Datalight optical system. Still, for each of our focusing monocolor and bicolor LED lights, we had to design new optics, and we feel that we've been successful in this, having gone through many stages of development and evaluation. Now we have LED bicolor lights that go from 2700 Kelvin all the way to 6500 Kelvin. And they stay perfectly at home on the Planckian curve. We identify each individual production run of our LEDs with binning numbers and other critical evaluations on each individual light head. So when we need perfect matches, they can be founded and based on augmented by other data lights for absolute precision matching, if necessary. One of the key issues with LED is the expectation of lifetime. In the internet, you'll find claims of a lifetime of 50,000 hours and above. In reality, in our profession, that depends to a large extent on the heat. Now, there are misunderstandings, since we often assume that LEDs create no heat. To some extent, that is even true regarding the forward emitted light rays from our lighting instrument, which carries little heat. But on the LED light source itself, tremendous heat is generated. And if that exceeds 80 degrees, the LED will get very sick. If it goes to 100 degrees, the LED is dead. Therefore, cooling is of utmost importance. Now, in order to not build gigantic instruments with large surfaces and a lot of fins that can work, and that what we call passive cooling. But then there's another kind of cooling that we hesitate to call cooling with fans and ventilators. Because in our profession, those are absolutely no-go words, and the sound man goes wild. Therefore, we can even avoid this vocabulary and call this active cooling. It was a long development to be able to build lights that optimize the size and the maximum permissible temperature on the LED light source by employing fans that run practically noiseless. With our focusing LED lights, we've reached that, and we call those turbo lights, as a symbol for a fan that indeed is employed. But at the same time, we call them whisper lights, because you don't hear them. Put your ear next to them, and it sounds like a lazy bee in neighbor's garden. Hold it 1 meter away from your ear, and these lights will be inaudible. Now, for larger sized LED light sources, we had to go one step further. And here we employ a very modern way of liquid cooling, where some cooling liquid takes the heat away from the LED light source itself, leads it to the cooling surfaces, and those again are cooled with a very slow-moving, super quiet fan. That again took us several years to perfect this technology. And we're proud to say that it finally all works to our satisfaction. But since we're now looking into larger LEDs with even higher power, we have to expect that again, the design and all the testing involved to make it all work may still take again a long time and many different approaches for the superpower LED light sources. That we already have, but we need to integrate them to now cooperate with new optical designs and new advanced supercooling systems, borrowed to some extent from computer technology. Maybe it is still worthwhile to add that our monocolor LED lights stay as close as possible to the book values. For the tungsten light with 3200 Kelvin, for the daylight as close to the value of the theoretical daylight with 5600 Kelvin, whereas our bicolor lights go below and above these values, namely from 2700 K all the way to 6500 Kelvin.